Hey everybody, it's a pleasure connecting and with you all, and thanks for your time and joining today. My name is Paul Zhao. I'm the principal product manager for Amazon Transcribe and also Amazon Transcribe Medical. I'd like to take just a brief bit of time of yours today to kind of share with you how speech to text at AWS is really transforming healthcare, and how we're working together with not just our own service and features, but also with sister services to kind of enable solutions to address a variety of fascinating use cases out in the real world. So as part of our journey today, I'll cover what the service does, and then I'll have at the very end, a demo to share with you all. And then at the very, very end, I'm happy to take some questions and do a quick Q&A. And if we run out of time, we don't have anything else, time to cover any questions, I'm happy to connect with you all directly. You'll have my email contact here. Happy to answer any questions. So, just at a high level, kind of sharing where Amazon Transcribe Medical sits within the AWS stack, right? So at the AI language services bucket, that's the grouping. In that org, we have a bunch of speech services, a bunch of language services, really. And Transcribe Medical is one of them. Specifically, it addresses speech to text, and all the models there are tuned for the medical domain, tuned for healthcare, right? Life science use cases. So what does the service do? As I already mentioned, it's speech to text, but more importantly, it's a fully managed automatic speech recognition service. That means we handle all of the back-end nitty-gritty model building. You don't really have to think about it, worry about it. We take that burden. We offer state-of-the-art medical transcription, all of which is powered by deep learning. And the whole point is to expose to users a set of super easy to use APIs. So all you got to do is call the API, pass us the audio, and then you're going to get a bunch of medical text in return. It's pretty straightforward. Some of the use cases, I always like to begin here because it helps set context, is one, in clinical documentation. We see a lot of demand for using medical transcription to build solutions like an ambient voice scribe, for instance, or to build things like clinical dictation applications. A clinical voice scribe right now is in its early stages of what we see in the marketplace with a lot of our partners and collaborators. And this is really a passive device that's intelligent. It's integrated with hardware like speaker systems that sit in a clinical environment and is able to automatically use Transcribe Medical in the background to capture and transcribe that medical conversation, say between a clinician and a patient. The clinical dictation app is more geared towards single speaker use cases where, say, for instance, a clinician is trying to capture post-patient encounter notes, where they're just trying to recall and document by verbalizing the medical notes directly. In a different arena for pharmacovigilance and also insurance analytics, we're really focused on enabling contact center analytics here. So a lot of folks in pharmacovigilance will call in to report on drug safety monitoring events or adverse events. Similarly, in contact centers and analytics space, insurance analytics, we have a lot of claims being filed, a lot of users who check in on their statuses, on what's covered, what's not. So in both cases, these are subsegments of the contact center intelligence, and Transcribe Medical can power both scenarios to, again, capture that speech, capture that conversation, transcribe it into text for downstream analysis. A growing segment now is in telemedicine. As you can imagine, with the recent pandemic that's been going on for a little while now, more and more clinical engagements are happening remotely. And so for that, Transcribe Medical can be super useful for adding subtitling to either engagement recordings through video or real-time video engagements in telemedicine. So getting a little bit into the details of how Transcribe Medical works. As I mentioned, it's speech to text, and then we actually offer two modes. One is the asynchronous or batch mode, and that's primarily used for transcribing existing audio or video content, right? So that's, you want to punch through a huge backlog of media, and you use this API to essentially set up large-scale job queues to handle parallel processing of a lot of audio transcription. And we support popular formats like WAV, MP3, MP4, and FLAC. And a lot of your rich media content, here, are going to be 16 kilohertz or higher, and we can support all of the above. Then the second mode of use is our synchronous or streaming or real-time API. There's all of which is addressing the same use case, is that it's the real-time transcription. Here, it's the same thing, except the difference you're not passing an existing audio file. You're instead passing to our system a live or a real-time audio stream. But the principles are the same. You can create multiple streams for your live transcription needs, and then we pump back to you a live stream of transcribed text. Right now, we currently support the popular LPCM 16-bit encoding, and we support WebSocket secure as far as protocols go. I'm kind of going to be doing a little bit of a deep dive into each one of these major features that we support Transcribe Medical. I'm happy to go further when we get to the Q&A. But for now, what Transcribe Medical supports is transcription in US English. US English obviously is a very diverse accent language pair, increasingly diverse over time as more and more demographies are part of this broader population. So it might include things like Chinese accents in English or Indian accents in English, for instance. And in these cases, we continue to not only support US English as a body of language accent pair, but also expand on the diversification of these accents to ensure that we're driving better performance for transcription overall. As far as the medical lexicon goes, we support transcription for the larger bucket called primary care, which spans family medicine, internal medicine, pediatrics, OBGYN. We will be adding additional specialties in time, things like oncology, cardiology, radiology, etc. And I'm happy to go into some of the roadmap items later in the Q&A. We also feature two modes or two speech dynamics. Earlier, I alluded to two use cases in clinical documentation, one of which was the ambient voice scribe and the other was the dictation app. And so symmetrically, we have two speech dynamics that we enable as well. One of them being the dictation mode. This is, again, for more single speaker clinician, doing a post-patient transcription of their notes. And then in parallel, we also support conversational transcription, which is the other speech dynamic, and that's to capture, multi-speaker conversations that can be 2 or 3, all the way up to 10 speakers, and we're able to actually help label each speaker within the transcript themselves. And I'll get into that in a little bit. Our service offers automatic punctuation and capitalization. So gone are the days where you have to explicitly say things like, patient came in complaining about a headache, period, or exclamation point. We'll automatically handle any sort of that punctuation and also handle all of the capitalization. And this is very, very important for a lot of instances in which we're doing text normalization. For example, with abbreviations like milligram, we'll properly capitalize or lowercase those terms. All of our output transcripts come with word level timestamps. So if you were to pop open the transcription file itself at the end of every transcription job, you'd see that every word has a beginning timestamp and an end timestamp. A lot of times customers will use this, with the explicit purpose of wanting to match up with video tracks, right? Because they might be in the use case of telemedicine and wanting to match up the transcription output with the video. All of our transcripts also feature word-level confidence scores. So a word-level confidence score is not to be mistaken with an accuracy rating, right? An accuracy rating talks about, whether or not this is in fact the correct word that was transcribed. But a confidence score tells you how confident, right, that we are in getting a particular term right or wrong. So we might have gotten the word right, and we also output a confidence score that's 90%. Conversely, although less likely, is that we got a word right and then we have a confidence score of, say, only 5%. In general, you'll see correlation between confidence score and the actual accuracy of the transcription term. How do people actually use confidence scores? Well, oftentimes they'll build it into their application logic and use it as a heuristic or some sort of proxy to determine whether or not they want to, say, suppress certain words that have low confidence, or maybe use it as a trigger and a flag to alert a human in the loop to go check in on that term. Right. And especially in medicine, we want to make sure that we're able to give visibility to instances of transcription where we don't have high confidence so that we ensure to close those gaps and go and button things up. Our service also offers something called alternative transcripts. True to its name, if you were to turn this feature on, you'd be able to see not the primary output of the transcription, but you also see our second best prediction and third best prediction, all the way up to a maximum of 10 best predictions. The predictions themselves are, or hypotheses transcripts, are actually all ranked in order of confidence scores. Most often, the case will be that the highest or the first transcription output is going to be the most accurate. But for completion's sake, we decided it would be helpful to let all users see what alternative guesses we made. And then that will give you additional optionality if you, say, wanted to explore one-off terms that might have been mistranscribed in one of the following options within the total set of transcript alternatives. Transcribe Medical also offers channel identification. So as many of you probably already know, audio can have multiple channels or it can have single channel. An example of that might be stereo, left-right channels, for instance. Another example might be in contact centers, you have a caller channel and an agent channel. In that case, it might behoove you to actually want to transcribe each speech channel separately. So we have this feature called channel identification that identifies, separates, and then simultaneously transcribes each channel's audio independently. The beauty of this is that we don't charge you multiple times like some of our competitors do. We just charge you one time. The second part of the advantage is that if you were to have, say, for example, one speaker per channel, you could effectively use channel identification to separate out different speakers. Speaking of speaker separation, this takes us to something called speaker diarization, which is nothing more than a fancy term that says I'm able to use my system and detect how many speakers there are and which speaker is saying what. This is not to be confused with speaker identification in terms of speaker profiles. So when you turn this feature on, you'll be able to say speaker 1 said A, B, C, D, E, speaker 2 said X, Y, Z, for instance, but it would not say Paul said X and Jason said Y, for instance. Nonetheless, having the speaker separated and having even basic labels like speaker 1 and speaker 2 gives you that visibility and optionality to attach additional customizations on those speaker labels if you should choose to do so in your application build. Last but not least is something called custom vocabulary. Custom vocabulary is a very straightforward list of terms that you populate and you use to tell our system to recognize these terms better. In other words, like any sort of speech recognition service, we may have what's called out-of-lexicon terms, meaning there might be a drug name that's so new that we haven't had a chance to integrate it into our speech training just yet. In that case, you're able to upload a list of terms, which includes, for example, that new drug name, and then inform our system to better recognize it and transcribe it whenever it is that our system hears it within your audio. Very briefly on data and privacy, our service is HIPAA eligible today. We're a stateless service, and what that means is that we do not store any inbound audio that you send to us, whether that's a live stream or whether that's an audio file for transcription. We also don't store any of the output text, again, regardless of whether that's in a live use case or a batch use case. So all of our transcription, that process is handled in memory, and at the end of every connection or every transcription job, nothing hits our disk, nothing is stored long form. The alert that we usually call out here is because of that, you as a user would often need to store those transcripts on your own terms, maybe in your own local environment or self-managed S3 bucket, because once those connections are closed, our service no longer retains that data. I'm going to transition right now to show you guys a quick demo. The context here is that we've actually coupled together two services. So the Amazon Transcribe medical service, which is capturing all of the speech transcription. And then on the back end, we have a service called Amazon Comprehend Medical, which is the medical text analytics service. In this demo, we show you how to actually ingest it, the audio in real time, transcribe it, and also how Comprehend Medical can analyze the text that's output. I'm just going to transition my audio here. Bear with me 1 second, please.
Hey, Paul, I think we cannot hear the audio. We might have to try it again. And guys, in between, Paul is trying. If you have any questions for Paul, do feel free to post in the chat window that we have here.
Patient is a 49-year-old male who recently sustained a traumatic injury to his left thigh during a boating accident. He was airlifted to the nearest hospital where he underwent extensive surgery and was later discharged. He has been admitted today due to his non-healing surgical wound. He still has the external fixation on it for the healing fractures in the leg. The patient has several areas of hypergranulation tissue right along the graft site. He has some drainage from these areas, but there are no signs or symptoms of infection. He has a temperature of 98.7 degrees Fahrenheit, and his current medications include Cipro and Flagyl. He is referred to us to help him get those areas under control. The patient will receive a series of treatment with chemical cauterization until these wounds are closed.
So what you just saw there was actually Transcribe being run in real time. We pre-recorded a file and we pumped it through our real-time API just to show you how it actually looks on screen. But pardon me, let me just make sure I'm on a good screenshot here. So what you recognize is that we're pretty fast. The real-time transcription is happening on the fly. And what you also saw was probably these partial transcripts, right? It was popping up onto the screen. And then as more and more spoken context started to land, you saw the transformations happening to the preceding text. Then finally, when the system determines that it's got a full sentence, for instance, transcribed properly, it'll all snap into place neatly. In this demo, we've also showed that we can recognize relatively complex terms, right, such as temperature, normalize that in numerical formats, and also be able to handle terminology like Cipro and Flagyl, which are medication names, and also be able to recognize different types of medical terms, such as graft sites, hypergranulation tissue, et cetera, et cetera. So that's kind of a quick snapshot of how Transcribe actually works, if you were to visualize it. And I'm happy to take any questions from here on out.